Okay students, today's script from TrignoScience Academy is about mixtures, substances that make up most of what we use in our daily lives, from the air we breathe to the food we eat. Why is seawater salty but still drinkable after purification? Why does milk look white even though it contains water, fat, and proteins mixed together? To understand this better, let's break it down step by step. 1. Definition of mixtures. A mixture is a combination of two or more substances physically combined, not chemically bonded. Mixtures retain their own properties and can usually be separated by physical methods. 2. Types of mixtures. Homogeneous solutions. Uniform composition. For example, sugar in water, air. Heterogeneous, not uniform. Components visible. For example, oil in water, sand in salt. 3. Separation methods based on properties like solubility, boiling point, particle size. Filtration progresses to separate insoluble solids from liquids. Evaporation progresses to recovers solute from solution. Distillation progresses to separates based on boiling point. Fractional distillation progresses to separates multiple liquids, for example, crude oil into petrol or diesel. Chromatography progresses to separates substances by movement across a medium, for example, pigments. Centrifugation progresses to separates fine particles by spinning. 4. Importance of mixtures. Natural resources, seawater, ores are mixtures. Industries rely on separation, petroleum, pharmaceuticals, food. For the detailed experiments related to this lesson, including purpose, steps, observations, and scientific reasoning, you can follow them in the TrignoScience Academy official sessions. Here's a situation you might notice around you that explains this idea. Petroleum refining through fractional distillation provides fuels and chemicals. Purification of drinking water involves filtration and chlorination. Medical labs use centrifugation to separate blood plasma from cells. Exam. Expecting questions. 1. Define mixture and give one example each of homogeneous and heterogeneous mixtures. 2. State two differences between a mixture and a compound. 3. Explain fractional distillation with one industrial use. 4. Describe chromatography and its principle. 5. Draw a simple diagram for separating a mixture of sand and salt. So to recap, the main points we covered today are: mixtures are physical combinations of substances, classified as homogeneous or heterogeneous, and separated by physical methods like filtration, distillation, and chromatography. Students, today you learned mixtures with its key ideas. If this helped, like the video, drop your answers in the comments and subscribe so you never miss future lessons. And don't forget, follow TrignoScience Academy on Instagram, TikTok, and Facebook for more science updates.